Hello, my name is Valerie Wang. I'm from National Tsinghua University in Taiwan. In this video, I would like to summarize a paper that we submitted to the Astrophysical Journal, which was recently accepted for publication. It is about the ALMA detections of O3 and C2 emission lines from one of the most distant galaxies, A1689-zD1, at a redshift of 7.13. And these are my fellow collaborators who also contributed a lot to this project. As I just said, A1689-zD1 is one of the most distant objects found with determined spectroscopic redshifts. And so, it is useful to probe the early universe, that is, the epoch of reionization, considering its redshift of around 7. With the ALMA archival data, it is the very first time that we detect the C2 and O3 emission lines of these galaxies because of the higher spatial resolution of both band 6 and band 8 of ALMA data, which is both around 0.2 arcsecond. And from both of the spectra, we can clearly see that there is a red-shifted and a blue-shifted components of this galaxy. And because these C2 and O3 emission lines are finite features that we can see in a spectrum, as compared to the Lyman break observed in Watson et al. 2015, which is a rather broad feature, we are able to correct the estimated redshift of 7.5 and correct it to 7.13. As seen in the HST images from Watson et al. 2015, this galaxy looks like some point sources. But with the higher spatial resolution of the ALMA data, it actually allows us to make an O3 to C2 luminosity ratio map rather than just some point sources. What is interesting is that from what we measured as a whole, we found that the average luminosity ratio of O3 to C2 is only around 2. But as we see from this ratio map, luminosity ratio map, the ratio can actually goes up to around 7 at the center of this galaxy. But what might have caused this particularly high ratio at the center? There are 3 scenarios that we can think of. First of all, it might be that there is an active galactic nucleus, AGN, sitting at the center of this galaxy. Or second, maybe there is a sharp heating, which has caused this ionization of the gases. Or maybe there's a central starburst at the center of this galaxy, which also ionizes the gas. But which one is the most accurate scenario? We are not sure yet. We also plot the moment 1 maps of C2 and O3 emission lines, which is also known as the flux-weighted velocity maps. And we see that for Clump 8, the upper part of this galaxy, there is a clear blue-shifted part on the east side and a clear red-shifted part on the west side. As for clump B, the bottom part of this galaxy is more likely a cloud of mildly redshifted and blue-shifted mixture. And we compare it to what was shown in the HST images from Watson et al. 2015. Overlaid are the moment zero maps of O3 and C2 lines. And we can see that this redshifted part in clump A is absent in optical wavelengths, as in the HST images. So what we are thinking is that this A1689-zD1 might be a merger with some northwestern ejected materials, or maybe it is a merger with some northwestern redshifted materials coming from a third and more highly obscured region, but we're not sure yet. So, as compared to what was seen before in the optical wavelengths, what we can conclude now is that this A1689-zD1 is a merger, but it is with complex kinematics because of this mysterious redshifted parts that is not seen in optical wavelengths. So this summarizes the paper that we submitted to APJ. If you have any questions, feel free to drop me a message, and we are happy to discuss with you further. Thank you very much.